Welcome to the UCL Centre for Anaesthesia Single Best Answer series. Don't worry if you don't know the answer straight away. They're meant to stimulate your learning and develop your critical thinking. If you want, you can discuss the answers with your tutor or an anaesthetist in theatre. Press pause now when you're reading the questions and then play when you're ready to see the answers. Okay, so what have we got here? I've deliberately not given you much clinical information. Of course, in real life, we'd have taken a brief history, examined the patient, and maybe had some other investigations. Or, if the urgency is such, Dr. ABCD, of course. So, from the top, we're looking at the pH. Of course, it's alkalemic, so an alkalosis must be driving that. Second, then the CO2 is low. Well, a low CO2 can cause the pH to rise. That is a respiratory alkalosis, causing a respiratory alkalemia, if we're being really precise. The next question then, because don't forget there are only three bits to the acid base. There's the pH, CO2, and the metabolic component, whether you think about bicarb or basic S. So the third component then is there any metabolic acidosis, alkalosis, or is there no metabolic issue? So, of course, a metabolic acidosis would be the compensation for a respiratory alkalosis, because they go in the opposite directions. But the metabolic compensation takes, from 6 hours, maybe 12. So if this problem's only been there for a few hours, it's unlikely that there's been any metabolic compensation. But of course there can be a independent metabolic problem. But here there appears to be no metabolic problem. Why do we say that? Because the base excess is normal, as is the bicarbonate. Don't forget, the base excess and bicarbonate go in the same direction by basically the same amount. When we look at the answers, respiratory alkalosis A with metabolic compensation is the same as answer C, isn't it? Because the metabolic compensation to a respiratory alkalosis would be a metabolic acidosis. The answer is B, because there is just a respiratory alkalosis, the pH is high and the CO2 is low, and there's no change in the metabolic component. I threw in a little curveball there. E, type 2 respiratory failure. Well, the oxygen is elevated, therefore the patient must be receiving oxygen, so it's very hard for us to say whether there's any respiratory failure. Of course, if the CO2 was high, there may be ventilatory failure, but strictly we can't really say whether it's respiratory failure because we can't say what the PO2 is. Have a look at the next slide, where really I've talked about the causes of respiratory alkalosis. The causes of respiratory alkalosis are anyone hyperventilating, overventilating if you like. So central nervous system issues, they may be hypoxemic. Well, this person is not hypoxemic, clearly. There may be drugs, stimulatory drugs causing it, whether therapeutic, overdose, endocrine hypermetabolic issues, a primary respiratory problem. So in pneumothorax, you'll hyperventilate. Pulmonary embolism, this person's post-op, so that should be on your mind. And of course, if you are ventilating someone in critical care or theatre too much, they will have a respiratory alkalosis.